Hello everyone, welcome to my channel. My name is Vidya and today's topic of discussion is to solve numericals on Euler's Totient. I have covered the concept and formulas for Euler Totient in my previous video. However, we'll first quickly revise the formula of computing Euler's Totient and then go ahead with solving the numericals. First and foremost, what is the information provided by Euler's Totient? So Euler's Totient of a number n, which is also denoted by phi of n, provides the count of numbers that are relatively prime, or which we also call as co-prime to n. So Euler's Totient of a number provides us with the count of numbers that are relatively prime to number n. And how do you compute the Euler Totient? For this, we look into the formulas for computing Euler Totient of any number n. In order to know the formula to compute the Euler Totient, we'll consider the number n in following three categories. First is the number n is a prime number. Second, if n is a composite number. And third, if n is power of prime number. If n is a prime number. Now, what is a prime number? I have covered it in detail in my previous video. However, I'll quickly discuss it here as well. So, n is prime if it is divisible by two numbers, by 1 and by itself. So, divisible means when you divide n with any number, your remainder should be 0, or you should not get any fractional number. So, prime numbers are the numbers which are divisible by only two numbers, that is by 1, and it should be divisible by itself, that is n. So when you divide n with 1 or when you divide n with n, then and then only the remainder is 0. Otherwise, if you divide n with any other number, it will result in a remainder. So such numbers are called as prime numbers, and if n is prime, the Euler Totient is computed by formula n minus 1. Now, second category of number is composite numbers. So a composite number is a number which can be represented by product of two prime numbers, p and q, and p and q are prime numbers. So what is the formula to compute Euler Totient of n? If n is composite, the formula is p minus 1 multiplied by q minus. Now, the third category of number is power of prime number. That is, if p is a prime number, then the number n can be represented as the power of prime number. That is, p raised to the power of e. So, if n is represented as p raised to power of e, in that case, the formula of Euler Totient is you do p raised to power of e minus p raised to power of e minus 1. We'll now go ahead to solve the numericals based upon these three formulas, but for that you should be able to identify if the number n is a prime number. If it is a prime number, that is, if it is divisible by 1 in itself, you will use the first formula, that is phi of n is n minus 1. If your number n is a composite number, that is, n is a product of two prime numbers, in that case you will be using the formula phi of n is equal to p minus 1 into q minus 1. If n is power of a prime number, that is, n can be represented as p raised to power of e, you will be using the third formula, that is phi n is p raised to power of e minus p raised to power of e minus 1. So let us now go ahead with solving few of the numericals. Let us first compute the Euler Totient of number 5. So we have to find the value of phi of number 5. So the first step that you have to do is to identify if the given number is a prime number. So what are prime numbers? Prime numbers are the numbers which are divisible only by two numbers, that is by 1 and itself. So if you check 5, if you divide it by 1, it is divisible, but at the same time, if you divide it by 2, it leads to a fractional number. If you divide 5 by 3, you again get a fractional number. If you divide 5 by 4, you again get a fractional number, but if you divide 5 by 5, you get 1. And if you divide 5 by any other number which is greater than 5, it will definitely lead to a fractional number. Therefore, as you can see here, 5 can be divided by 1 and 5 can be divided by 5. So, since 5 is divisible by only two numbers, that is 1 and 5, that is 1 and itself, 5 is a prime number. So since 5 is a prime number, we now use the formula of Euler Totient for prime number. What is the formula? It is n minus 1. So what is the Euler Totient of number 5? It is 5 minus 1. What is the answer? 4. So we got the Euler quotient of phi as 4. And what is the meaning of this answer? The meaning of the answer is there are in total 4 numbers in the range 1 to 4. Why 4? Because the last number into consideration is always n minus 1 are relatively prime to 5. So this is the information that is provided by Euler's quotient. Let us now check out the second numerical, that is what is Euler quotient of 10. So we have to find Euler quotient of 10. Now if you see the number 10, you already know it is a product of 2 into 5, and you already know 2 and 5 are prime numbers. So 10 is a composite number which is a product of 2 prime numbers, and since n is a composite number, so Euler quotient of number n, that is the Euler quotient of p into q, is always given as p minus 1 into q minus 1. Therefore, the Euler quotient of number 10 is given as Euler quotient of 2 into 5, that is 2 minus 1 into 5 minus 1. So 2 minus 1 is 1, 5 minus 1 is 4, and the answer is 4. Therefore, the Euler quotient for number 10 is 4, and it indicates that there are in total 4 numbers in range of 1 to 9. Now why 9? Because the last number into consideration is always n minus 1, that is 10 minus 1, which is 9. So there are 4 numbers in the range of 1 to 9 which are relatively prime to 10. What is relatively prime? Relatively prime means the GCD of those numbers, let us call those numbers x, with respect to 10 is equal to 1. So there are 4 numbers x whose GCD with respect to 10 is equal to 1. So Euler quotient just gives us the count. Euler quotient does not tell us which are those numbers. So we do not know which are the numbers x, but definitely we know the count using Euler quotient. Let us now check out the Euler quotient of number 16. So we have to compute Euler quotient of 16. Now if you check the number 16, it can be written as 4 into 4, and 4 is basically 2 raised to the power of 2. So we can also write this as 2 raised to 4. So 16 is nothing but it is 2 raised to power of 4, where 2 is a prime number. Therefore, number n in this case is written as the power of a prime number. So we find the Euler quotient of any number n which is a power of prime number as p raised to power of e minus p raised to power of e minus 1. So we have to find phi of 16, that is we have to find phi of 2 raised to 4. How can you find it? It is 2 raised to 4 minus 2 raised to 4 minus 1. So 2 raised to 4 minus what is 2 raised to 4 minus 1? 3. What is 2 raised to 4? 16. And what is 2 raised to the power of 3? 8. So 16 minus 8 is 8. So the Euler quotient of 16 is 8. And as I have told you, what is the meaning of this number? It indicates that there are total 8 numbers in range from 1 to 15 which are relatively prime to 16. What do you mean by relatively prime to 16? That is GCD of those 8 numbers denoted by x with respect to 16 is equal to 1. So there are in total 8 numbers which satisfy this condition. Let us now solve this question. So what is the Euler quotient of 11? As you can see, 11 is a number which is divisible only by 2 numbers, that is 1 and itself. Therefore 11 is a prime number, and the formula that we use for Euler quotient of prime number is n minus 1. Therefore phi of 11 can be computed as 11 minus 1, which is 10. So phi of 11 is equal to 10. And what is the information it gives you? There are a total of 10 numbers in the range 1 to 10. Now why the last number is 10? That is, we were asked to find the Euler quotient of 11. So the last number you are going to test is 11 minus 1. So there are total 10 numbers in the range of 1 to 10 that are relatively prime to 11. So there are total 10 number x that satisfies the condition GCD of x with respect to 11 is equal to 1. So let us solve this question. We have to compute the Euler quotient of 21. As you all know, 21 can be represented as 3 into 7, where 3 and 7 both are prime numbers. So 21 is a composite number, and the Euler totient of a composite number is given as p minus 1 into q minus 1. Therefore, the Euler's totient of 21, that is the Euler totient of 3 into 7, can be computed as 3 minus 1 into 7 minus 1. So 3 minus 1 is 2, 7 minus 1 is 6, and the answer is 12. Therefore, the Euler totient of 21 is equal to 12. And what does the answer indicate? The answer indicates that there are in total 12 numbers in the range 1 to 20 which are relatively prime, or which we also call as co-prime to 21. And what do you mean by relatively prime or co-prime number? That means there are total 12 values of x which satisfy the condition GCD of x with respect to 21 is equal to 1. So there are in total 12 values that satisfies this particular condition. Let us now check out the next question, that is compute the Euler totient of 240. Now if you check this number 240, it is a large number, and in a glance we cannot split up this number. Whenever a number is large, the first step is we split up the number into its prime numbers. Now how do we do that? So you take 240 and divide it by the first prime number. Which is the first prime number? It is 2. Keep in mind the initial prime numbers till 10 are 2, 3, 5, 7, 9. So you take the number and divide by first prime number, that is 2, and the remainder should be 0. So now again you divide by the prime number, remainder is 0. Again you divide it by prime number, you got the remainder 0. Again you divide it by the prime number, so 2 into 15 you get remainder 0. Now you got 15. So now if I divide 15 with 2, I will get some remainder. Well, I should not get a remainder, I should get a remainder 0. So which is the number that will result in remainder 0? It is 3. So 3 into 5 is 15 and remainder is 0. Now again 5 can be divided by prime number 5 and result in remainder 0. So we can represent 240 using these prime numbers. That is 240 can be represented as 2 raised to power of 1, 2, 3, 4. So 2 raised to power of 4 into 3 into 5. So we have represented 240 in product of its prime numbers. So now we want to find the Euler totient of 240. That is, we want to find Euler totient of 2 raised to power of 4 into 3 into 5. That is Euler totient of 2 raised to power of 4 into Euler totient of 3 into Euler totient of 5. Now what is the Euler totient of 2 raised to 4? You can compute it as 2 raised to 4 minus 2 raised to 4 minus 1. That is 16 minus 8, which is 8. What is the Euler totient of 3? 3 is a prime number, so we can calculate it as 3 minus 1, which is 2. And what is the Euler totient of 5? 5 is a prime number, so you can calculate it as 5 minus 1, which is 4. So substituting these values, that is Euler totient of 2 raised to power of 4 is 8, Euler totient of 3 is 2, and Euler totient of 5 is 4. So you get your final answer, that is 64. So the value of Euler totient of 240 is 64. And the answer indicates that there are in total 64 numbers which are unknown. So you know the count, but you don't know the numbers in Euler totient. So there are in all 64 numbers x in the range 1 to 239, because our number which we are testing is 240. So we have to test numbers in the range from 1 to 240 minus 1. So there are in total 64 numbers in the range 1 to 239 that are relatively prime, or which we also call as co-prime to the given number 240. And what do you mean by relatively prime number or co-prime number? It means that if you check the GCD of these 64 numbers, which is denoted as x with respect to 240, the greatest common divisor is 1. So there are in all 64 numbers which satisfy this particular condition. Let us check out one more question, that is compute the Euler totient of 210. So we have to find phi of 210. So the first step is 210 has to be represented as product of or in terms of prime number. So we already know what are the prime numbers. So 2 is a prime number, 3, 5, 7, 9, 11, 13, 17, 19 are the prime numbers from 1 to 20. Therefore, in order to split up the number 210 into prime number, you divide the number by prime number, but divide it with such a kind of prime number which will result in remainder 0. So here, as you can see that if I divide 210 with 2, I get the answer is 105 and my remainder is 0. So now 105 has to be divided by such a prime number which results in remainder 0. So which is that? So if I divide 105 with 5, 5 into 21 is 105 and the remainder is 0. Now 21 when divided by 3 into 7, I get the remainder 0, and 7 into 1, the remainder is 0. Therefore, 210 can be represented as 2 into 5 into 3 into 7. Therefore, the Euler quotient of 210 is nothing but the Euler quotient of 2 into 5 into 3 into 7. So, we first decomposed the number 210 into its prime numbers, that is 2 into 5 into 3 into 7, which can be written as phi of 2 into phi of 5 into phi of 3 into phi of 7. Now you already know each is a prime number. So 2 is a prime number, so its Euler quotient is 2 minus 1. 5 is a prime number, so its Euler quotient is 5 minus 1. 3 is a prime number, so its Euler quotient is 3 minus 1. 7 is again a prime number, so its Euler quotient is 7 minus 1. So 2 minus 1 is 1, into 5 minus 1 is 4, into 3 minus 1 is 2, into 7 minus 1 is 6. Therefore, the Euler quotient of 210 is 48. That is, there are 48 numbers which are unknown, so I represent it as x, which satisfies the condition GCD of those numbers with respect to 210 is 1. So there are 48 numbers which are relatively prime to number 210. So with this we come to an end of this video. Thank you guys for listening to my video. In my next video I shall be discussing Fermat's theorem and Euler's theorem. These two theorems are basically used to test if greatest common divisor between two numbers a and b is equal to 1. That is, they are used to test if a and b are relatively prime, or which we also call as co-prime numbers. So see you guys in my next video. Stay happy, stay blessed. Bye bye.